Hello YouTube. So I've bought a new toy, or hopefully it'll be a useful tool. It's a 3D printing pen. Draw your dream printing pen. It's just a cheap Chinese model, I think. At least there is no actual brand name on the box, as you may be able to see. So let's see, it has a 0.6 millimeter nozzle. It runs on 5 volt DC, 2 amps, so just USB power. They claim it can print both PLA and ABS, although the working temperature only goes up to 210. That seems a little bit cool for ABS. Comes in different colors. And here's some examples of stuff you could do with it. In theory, I don't think we'll be doing that. That's not really why I've bought it. So let's have a look at what's inside the box. So first of all, we have the actual pen here. We'll have a closer look at that, of course. It looks quite nice, but honestly, it feels very chintzy and cheap. There's not much weight to it at all, and the plastic is very cheap. Underneath, we have some instructions. There's a failure recovery with some instructions. If you stop using 3D pen, remember to withdraw the filament in time to avoid filament cooling and block the pen. So before I turn it off, you're supposed to remove the filament apparently. And then some information about how to unclog it if you do get it wrong. And disassembly instructions and all. And yeah, I think we'll have a look inside it as well. Then there's an actual manual, I think, but it's just a A4 sheet of paper. No precautions. There is some operating instructions. Basically just plug it into power and get going. And then you can choose modes. We'll have a look at that. Screw the manual. And it comes with some sample filaments, PLA in various colors. Very small strips, it seems, not very long at all. It should use standard 1.75 millimeter filament. So I'm probably also going to try and take some from my big spools for the 3D printers and see if that actually fits. It should, in theory. Then we have some finger protectors, which are honestly too small for my fingers, so we won't be using those. We hope it doesn't get that hot that we will need them, but we'll see. Then it comes with a tiny stand, I think it is. So let's get rid of that. And that's just so you can put it like that when it's hot. Yes, so we'll keep that here. Then we have a USB cable and a USB charger. And now this should run up, it should use 2 amps, so hopefully this is a decent quality charger that actually can deliver that. Let's see, it does claim here, I don't know if you can read that, probably a bit hard, but it does say 5 volts, 2 amps AC adapter. And then there is some more. There's a little spatula. I'm not sure what this is for. Maybe forming the plastic a bit. Let's put that in the back here. And Then there's the actual operating instruction, which we already had a look at, but this is, well, both in Chinese and English. Yeah, not much there, to be honest. So let's try powering it up. Okay, so I've got the charger plugged in. While this is a charger, and you might be led to believe that this is wireless, it's not. It only operates when this is plugged in. So let's try turning it on. It's set to PLA right now, and you should be able to switch that. Let's just try that again. Not sure how to switch it. Oh, this button over here, ABS or PLA. And then you press that and it starts heating. It claims it's up to 60 already, so it heats very fast, it seems. And while that heats, just unpackage some PLA here. And I see I need scissors or a knife to get into this. It's not any easy way to get in there otherwise. Okay, so got the filament opened. So let's have a look at how long these pieces actually are. Let's see if we can untangle one of these. It's just all tangled together, so I'm not sure how you're supposed to get this apart. It's just one big mess. Okay, but it does look like it's actually some... I'm just getting... Okay, so it is actually a decent enough length for this purpose, I guess. This is, yeah, I don't know, 3 meters maybe? So that should be fine. And now it says it's up to 200 degrees. As we can see here on this little display. I don't know if the ad can be picked up on camera, it's not very bright. And let's see if we can hold it. Yeah, at least so far it's not very hot. This bit down here should, don't hold it too far, too close to the tip. That is hot, but you can hold it without those thumb protectors, it does seem. So let's see if we can load this. So we should be just inserting the filament up here, I'm thinking. And now I've gotta be careful. It doesn't really, I don't feel it going in there, but let's see if we can get it to feed. There we go. So now we're feeding. So if you press these buttons, yeah. So now I unloaded it. How do I get it to stop again? So I unloaded the filament, or retracted it. I can't get it to stop again. It just keeps going. So I guess you're only supposed to do that when you're done with your job, and then you have to unplug it, it seems. Maybe there's some combination I didn't figure out. Anyway. So we heat it again and see if we can get it to actually feed the filament all the way through. Now what I don't see here is there's some speed settings. So I guess this S1 means the lowest speed setting. S3, 2, 1. I'm thinking 1 is the lowest setting. Yeah, that's quite slow, but I think that's fine because you see Right now it's actually dropping the temperature, even though it's not actually, the filament hasn't actually reached the hot end yet. So why it's, or maybe it's just the way I'm holding it. It depends on where the sensor is. So if I'm holding it up, the heat will go away from the sensor maybe. I'm not sure. But it just keeps dropping in temperature, it seems. That doesn't seem very promising, to be honest. And I'm at the lowest speed setting, and I don't think that the filament is anywhere near the nozzle yet. No idea how far it's gotten. Let's try speeding it up. That's the max speed. Now it's just 200. I don't know. And it's feeding. And then it slowed down, so let's... And now it stopped. Okay. So let's see if we can get rid of this stringy piece here. So I don't know. Maybe it adjusts the temperature according to the speed. But yeah, so far it worked. So let's see if we can do something here. Now I don't know if this is a silicone mat. It probably won't really stick to this. Maybe it will. So let's just draw a square here. Oh, not quite. It won't really stick to this at all. So I gotta find something that I can print onto. Now if it only gets... So I was thinking of using a piece of paper, but if this was printing ABS, I was thinking that might be too hot. I might set fire to the paper, but now that I look at it, it only goes up to, right now it's sitting at 175. That should be good enough, or cool enough that I won't set fire to my house. So let's see if it will stick to paper. Okay, so we've got a piece of paper. Let's try that again then. Yeah, that seems a lot better. Well, not really good, but if you press it down a little bit, then it will stick. So let's see if we can do something with this. Actually controlling it and making anything like what was on the box, that's not easy. And you gotta keep your speed consistent. We are getting, I mean, I'm moving up in C height faster than I would on my 3D printers. But of course it's not nearly as nice. Yeah. Okay, so we've confirmed that this does indeed work, and with a bit of patience you could make, I mean, something out of this. Let's see if we can do some bridging action. Get it to just stick out in thin air. Nah, it's just melting the existing plastic. Okay, I think that's enough of that. And yeah, let's just blow on it to see if it is still fairly soft in some places. Not too bad. So I mean, with a bit of practice, you could maybe make something like those figures on the box. This obviously isn't very convincing, but it does the job, it looks like. So let's try loading some filament from my 3D printer just to confirm that it actually is using 1.75 filament size. So we unload this. Let's see how the end looks here. Yeah, pretty much like when it comes out of the 3D printer. And this time it actually shut off, so yeah, I don't know what happened before white just kept going. But this time it did actually shut off the motor or extruder. So I've got an old, almost empty spool of red filament here. Let's just snip the end here if we can. Yeah, there's not much left, but let's just see if it actually fits. So yeah, if you have to stock up on filament, I think it will be a lot cheaper to buy spools of it if you do this a lot. Although you would have to do it quite a lot. Let's see, do you want to feed? Yeah, okay. So we're feeding. That doesn't sound. I think it broke it. See if we can unload it. Yeah, it's broken inside. Well, no, it's not broken, it just didn't feed it. And now it has that problem where it doesn't shut off the motor again. I wonder if it's just a matter of waiting. There it goes. Let's try that one more time. Okay, so I'm wondering if we actually have a clog in there, because it doesn't seem like it will go in more than a few millimeters. Maybe the first time it went in 3-4 centimeters, and that seems to be about it. So I think I've clogged it already. I must say that's not very convincing. Let's just try doing it very, very slowly. Now it is eating the filament this time. And it's keep going, so yeah, I'm not sure. I mean, the extruder mechanism was working fine for the first, when I tried the sample. So yeah, I'm just gonna see if I can actually feed this all the way through, if I clogged it somewhere. And then we might just measure the filament to see if the samples we got are maybe a little bit undersized, since it seems to be struggling more with this. At least, yeah, if I stop pushing it, it's the extruder starts to clicking. Okay, we're getting out the black stuff on the other end now. So we are getting close, I think, I hope. Now also it's only running at 175 right now, it seems, at the low speed setting. In my opinion that's a little bit cool, but I don't think you can adjust it. But maybe there's some magic button combination that you can press to make that happen. Okay. It does seem like it's still feeding now. Let's just unspool some more here. So it will work with standard 1.75 millimeter filament, but it's not. It does seem to struggle a little bit. You can't just set it to the high speed setting and then expect it to go. Let's try that. Yeah, you can hear it struggling. Maybe. I don't know if that gets picked up on camera. Let me just move the camera close. So that's the low speed setting. That's the highest. And to me that sounds like a motor that's just about to stall. And that's the medium. Okay. Let's just stop this and see if we can get this to. And now I see a problem. The filament is actually tipping over this because the spool is kind of pulling on it. Let's just unspool some more and see if we can't get it to stay there. No. It really doesn't want to stay there right now. So this base could definitely use some more weight to it. Anyway, let's get on with it. So the reason I bought this was actually to see if I could use it as a repair tool for 3D prints. This is a planter that comes in two parts, self-watering. Put the water in there, and then here you'll plant your whatever it is. I mainly use it to grow basil. And let me just try and see if I can get these two parts apart. There we go. You can see it's already been used. But I have a problem with this. It's leaking. I've printed 5 of these and one of them is leaking. And you see I've had some under extrusion. I think my PTFE tube needs replacing. So in places I've had some under extrusion. And you can maybe see some discoloration right about here. And maybe even here. And that's the spots where it's leaking. So I was thinking, what if we can use a 3D print to just add a little bit of extra material in these spots where it's leaking, and then get this functional. Otherwise this is just trash as it is right now. So yeah, that's the idea. Although I'm a little bit worried that this is running too cool to really get good adhesion and stuff here. At 175, that's a bit too cool. So I think I might actually try just, let's see if we power it off and power it back on, and then press this button. It goes into ABS mode. And I mean, that should be hotter. So let's see if that'll work. Let's see what temperature it gets up to. Because like I said, I just think 175 at the low speed setting, and that's the only, I mean, it starts to struggle when you move up in speed. So that, to me, that seems like the low speed setting is where this will be best. But at just 175 degrees Celsius, that's a bit cool. I mean, I know you can print PLA down to about 180, 175 if it's actually accurate. Okay, that's maybe possible, but you're not really melting it. At least if you're going fast at that speed, you're not really melting the material. You're more like just softening it and pushing it through. And actually, most of my PLA prints these days are like at 210, 220 maybe even. And that may sound hot and for PLA, but if you're doing functional prints like this and you want really good layer adhesion, it's good to go high in temperature. So it's done heating and it's claiming it's sitting at 200 degrees now. Let's try changing to speed settings, then it should maybe go to, and 220 at the highest speed setting, but the low speed setting it's sitting at 200, I think. Yeah, it's dropping down to 200. Again, it's a tiny dark display, so I don't know if you can see it, but it is. So first of all, let's just double check that it hasn't clogged or anything, which it may have. Oh, it's coming there. Slowly. Yeah, and I can also already see that the consistency of the extruded plastic is quite different. So I think that's good. Even with PLA, if you maybe for the small figures, because of course you don't have any cooling here, so you don't want it too hot. But yeah, I don't think for my intended purpose, I think I'm just gonna be running it in ABS mode all the time. I do feel like it's getting a little bit hot now. Well, I can still easily hold it, that's not a problem. I can feel the heat creeping up the shaft a tiny bit. But it's been powered on for 10, 15 minutes or so. So let's just see if we can clean this stuff up, off the nozzle here. There we go. And let's see if we can do something about these cracks here. Of course, this isn't going to be the prettiest job, but then you could file it or sand it down afterwards. You might try doing that to see if you really got into the cracks here. Just gonna lay on a thick layer and then we're gonna file it down afterwards. I think that's about it for this spot. And we have a few spots here that's probably suspect. So we just go maybe this route in this groove here. So basically I'm thinking you can use this kind of like a plastic welder, maybe even glue, you maybe weld together some parts. Of course you can't get it all the way through, but you know, on the surface you could weld it. That might also be a use for it, other than filling, you know, on extrusions. So I think that's more or less it for this part. So we're gonna let it cool, then I'm gonna file that down a bit to see if it actually, well, to feel if it actually sticks and if we got into those screws. And then I'm gonna fill this with water and see if it's actually not leaking anymore. So I'll be right back. Here we have it. You can still see where I did the repair. And yeah, it's wet underneath because I washed it. What we want to see is if we see water actually pouring out of it. didn't bother to clean up these down here too much. They're kind of in the seam, so it's not too noticeable. It's full of water. Like I said, there's a little bit of moisture because I washed it, all the dust off of it. But the area you're interested in is right here where it leaked before. So I think I'm just gonna set this off to one side and get this out of here. And then I think we're gonna have a look inside this little thing. I should have unloaded the filament. I forgot that. So let's see if it's really true that you have to unload that before I turn it off, or if that's just a precaution. So let's heat it up, and then we'll see. I'm not sure it's heating right now. What the hell? Before it heated up quite quickly. Now it's heating. So it's taking a little while to start heating. Anyways, we'll get ready to disassemble it as well. Apparently it's just one screw holding it together as far as you can see, unless there's some clips. So just one little Phillips head in the back here. That's a bit too small. So get ready to do that. See how it's doing. 170. So I gotta say I'm impressed by how fast it heats. That's in my opinion quite impressive. I mean the extruders on my 3D printers, and they're like 25 watts I think, and this is 10 watts. And they take way longer to heat. So let's see if we can back this up. I want to go low setting. No, it is backing up. No problem. So there we go. Now it's hot, of course, so I really shouldn't be taking it apart right now, but screw it. So that comes off, and then how do we get the rest apart? Might have to look in those instructions. It does seem like it's loose here. Okay, here we go. There's not much to it. There's the motor up here that feeds, or the extruder that feeds the filament. Then we've got a control board, got the motor hooked onto that. And we've got power coming in here from the USB plug. Then we've just got a tube where the filament goes through the control board with all the buttons. And then the hot end is in here. We can't see that right now, but I mean, it's just a heating element. Nothing much to it. So yeah, I don't think I'll take it further apart. There's no need. It's a very simple construction. One note though, even though this is not battery power, so it's not wireless, you could, I mean, it just takes 2 amps at 5 volts. So you could run this off a power bank actually, if you wanted to. So that would be one way to make it more portable at least. So you don't have to sit close to a socket to use it. Yeah. Anyways, this, I think this is more or less it from me here. So far I'm quite impressed with it, even though it's very cheap feeling. It does the job, definitely. And if we look here, there's, yeah, it's not pouring out. It's a little bit moist here, but it's definitely helped. Maybe I'll need to give it another pass. But I mean, it did definitely fuse the filament into this. It didn't just crack off when I start filing it. It's definitely fused together. So I think, you know, if you need to repair 3D prints, this is, well, not the only way to doing it, but it's definitely a viable option, I'll say. And it costs me about, I'll throw in the link, but it's about $75, maybe less, 60 maybe even. It's not terribly expensive, but it's not like, yeah, extremely cheap either. And well, this does get very hot, so I wouldn't give it to small children to play around with, but I mean, 9-10 years of age, they could probably use this. You just gotta keep your fingers away from the black bit down there, and then you're actually pretty fine. So yeah, that's it for now. Like and subscribe if you liked the video. Until next time, take care.